Hello, I'm Anil Kumar. Welcome to my series on rational functions. Today, we are going to discuss reciprocal functions in particular. Well, reciprocal means if f of x is a function, then 1 over f of x will be reciprocal of the same. Now, since we have the variable in the denominator, it becomes a rational function, correct? And it will have restrictions. The function f of x, wherever it has zeros, will now be restricted for the rational function 1 over f of x. So those zeros can lead to the vertical asymptotes in this particular case, since we have a constant in the numerator and a polynomial in the denominator. So let us see, how do we define a reciprocal function? How do we graph? And from the graph, how do we get the equation of these reciprocal functions? We will also take a few applications, the real life applications related to work done on reciprocal functions. I hope you will enjoy this journey. So let's begin with our unit on reciprocal functions. Thank you.
Good morning, everyone. I am Anil Kumar. We are trying to review advanced functions, which is a curriculum in Ontario, Canada. We call it MHF4U. We have already done polynomials, and today we are going to begin with rational functions. The very first chapter in it is reciprocal functions. Well, before I begin, let me confirm with you, have you all understood everything about the polynomial functions? The average rate of change and instantaneous rate of change, right? Okay, great. So that's a good thing. And now today we'll talk about reciprocal functions. Let me share with you what I have prepared as a lesson for you. Can you all see my screen? Right, so.
Yes, sir, I have a question.
Yes.
Are we already done with polynomials, or are we going to come back to it?
We are almost done with polynomials, yes. Do you have any questions in polynomials which we can address?
No, I was just asking because on the textbook, I think, did we do like what, 0.1, 0.2, 0.3, 0.4, 0.5? Did we do like everything?
Yeah.
Okay.
So if you have difficulties with any of those questions, correct, you can always ask me, correct?
Okay.
We'll have a session where we can, after rational functions, we'll have a mid-chapter, mid-review, where we'll take functions, polynomials, reciprocal functions, and everything which we have done so far. Is that okay?
Okay.
Okay. So, Hamza, you had a question about polynomial functions. Can you please ask that question again?
No, I think you answered my question. I just asked if you're done like both polynomial chapters. That's just all I want to ask.
Perfect. So for polynomials, we have two units in this, unit 3 and 4, correct?
Mm-hmm.
From my side, I've actually taught you both the units, but you need to do some questions from the book. And if you come across something which you don't understand, ask me. Perfect?
Okay.
So we are now in unit 5, which is rational functions. Good. So in rational functions, we'll begin with reciprocal of a function. Reciprocal means, as shown here, if the function is f of x, then the reciprocal is 1 over f of x. Clear, right? Bold and clear. This is what reciprocal is. Any function I give you, reciprocal will be 1 over f of x, correct? Now, the function could be a linear function, it could be a quadratic, any polynomial, it could be square root, it could be sine x, any function which you have learned so far. Do not restrict yourself to only linear and quadratic as it has been dealt in the book. Get my idea? Most of the students actually fail to get very good marks because they think this particular chapter only deals with reciprocal of linear and quadratic, at the most some polynomial function. Is that clear to you? But you'll be surprised that in the test, they will ask you questions based on reciprocal of semicircle. You get the idea? Which is pretty difficult, right? If you haven't really done anything about it. You get the idea, right? So be clear in your mind, reciprocal means f of x could be any function which we have learned so far. And it could be any graph, okay? So that is first thing which we need to understand. I've given you some graphs here showing what kind of function could be and its reciprocal. So wherever these four graphs, there are two functions in them. One of them is the function itself. The other one is a reciprocal of the function, correct? You can actually easily figure out which graph is that of the reciprocal and which graph is that of the function. Well, both are interrelated, but for example, if I take up the very first graph and I say that the function is f of x, which is a linear function, in that case, the reciprocal is 1 over x, as you know, right? Both are parent functions, you know fairly well about them. The second graph, I can take the parent function is x squared and the reciprocal is 1 over x squared, the graph shown in blue. You get the idea, right? The third one is a cubic function, and the reciprocal is shown in brown color with some vertical and horizontal asymptotes also. Then we again have a function which is a quadratic function whose reciprocal is also shown here in the graph. Anyway, so when we try to understand this chapter on reciprocal functions, I would like to break it down into very simple steps. My step number one is to understand what are reciprocal values. Means if 5 is a value, then reciprocal of 5 is 1 over 5, correct? If minus 5 is the value, then minus 1 over 5 will be reciprocal. Just from the values, we learn a very important thing, that reciprocal of a positive value is positive, reciprocal of a negative value is negative. Clear? It also means that if the graph is positive, right, this half is positive, in that case, the reciprocal will also be positive. As you can see in quadrant 1, both function and its reciprocal are there. Both are positive. Is that clear to you? Similarly, if the function is negative, then its reciprocal will also be negative. That means it will be, both of them will be in quadrant 3. You get the idea?
Sir?
Yes.
So it matches like a positive to positive from the interval 0 to positive infinity, and then from 0 to minus infinity, it's both the function and its reciprocal are negative, right?
For the first graph, which is linear, right? Y to x. But the graphs could be different kinds. But the important thing here is, if the function is negative, for example, you see this portion of quadratic function is negative below the x-axis, correct? And the reciprocal shown in blue is also below the x-axis. You get the idea? So negative reciprocal is negative, positive reciprocal is positive. We all know it, but to understand and visualize is a different story altogether. It makes the whole chapter very simple. That's why I'm laying stress on this particular part, correct? Another important thing which you will see here is that, let's look into this line. So when you say y equals to x is your line, is it always increasing or decreasing? What is happening to this line? As we move from left to right, what is happening to this line? It is always increasing. Correct? No, reciprocal 1 over x will be always decreasing, right? Because the function was increasing, reciprocal will decrease. Make sense? As you can see, the reciprocal function in blue is always decreasing in its domain, right? That is what we say the characteristics of a function. So from the characteristics of the function, we can find the characteristics of the reciprocal of the function. Do you see that? So therefore, yes.
So to find the reciprocal function's characteristics, right, sir? Do we just do the opposite of what the initial function's characteristics were?
Yeah, there are many more things. We just talked about one. Yes, there are many more things, but they are all related, right? It doesn't matter what is the function. It could be square root function, right? I haven't drawn square root function, but I could draw one, correct? I could say my function is square root, right? And then I could sketch the reciprocal of this function. No problems.
Yeah.
Once I understand all the characteristics, this is important, right? So therefore, we'll understand the characteristics, how they are related between the function and the reciprocal, correct? And then we'll take up examples which are similar to your book, which deal with linear and quadratic function. We'll just add a polynomial also. It's kind of similar. Is that all? So that is what we are going to cover for now today. This forms us the base for it. And then in the next class, we are going to have a real quiz on reciprocal functions. along with introduction to rational functions, correct? Now let me today tell you what is a rational function. Rational function, let's say r of x, is a rational function which has a polynomial in the numerator. It is a quotient of polynomials. So we have a, let's say, a numerator, we have a polynomial, and in denominator also we have a polynomial. That makes it a rational function. And of course, denominator is never equal to 0, correct? We cannot divide by 0. So those will be the restriction in the domain of the polynomial in the denominator. Perfect. So that becomes the rational function, rest of the unit. Now there's one very important thing to understand. Rational functions do not include circles and semicircles and semicircles and exponential functions and square root functions, all those things, correct? Because once it is like to the power of half or 3 by 2, it is not a polynomial. You get the idea? So the rational functions, the rest of the unit, does not include any other function. It only includes polynomial over polynomial, correct? Perfect. And therefore, the book gives you an idea as if the whole unit is only about polynomials and nothing else. You get the idea? And surprisingly, the test does not reflect that. Test will have all the functions because f of x can be anything when we talk about reciprocal function. Correct? And then I could transform this function. If I transform this function, now there is no limit. I could make it anything. You get the idea? So what I'm trying to say is, look here very carefully. Before we really get into it, understand the critical part. This is a semicircle, correct? It is a function. I can ask you characteristics of reciprocal of transform semicircle. Not an easy job. For example, what I'm trying to tell you is this. I just transform it. Do you understand? And ask you reciprocal of this function. It is not easy. You understand square root of x square minus a square, and then that is being transformed. Not easy. You get the idea? What are the most difficult questions? Which will come from chapter 1. Yes.
So I was just thinking, so if you want to find the reciprocal of a function, couldn't you just plug in the values, but then just do like the reciprocal values? Like, for example,
yes,
like, you know what I mean? Yeah. So in a table, like if you were to make one value and it have a point, and then you put the transform point, and then you put the value of like the reciprocal, do you think that would work or not?
Yes, Hamza, that is exactly what will work. And therefore, I have split it into reciprocal values. Do you see the first thing? We'll begin from there only, reciprocal values. To be honest with you,
because that's like the easiest, like that's what I did like throughout like grade 11 for like sine functions. I plug in the value of sine 45. So that's what I always did. So can you just use that same like method?
Exactly. We can do that. Yes.
Okay.
We will do it. Right? We will do it. Okay. So this is the pattern which we are going to follow today. Does it sound interesting? I think this is the simplest way of learning this chapter, which actually becomes very complicated as you move along. Okay. You must have noticed this new logo on my YouTube channel. So that's my new logo, where we have an ocean and a road going on top of it. The whole idea of this logo is, let me share with you. It's a good time. On internet, there are thousands of things available, very brilliant ideas, and like the whole knowledge is there, right? But it's like finding a pearl in an ocean. It's very difficult to get the right person to get the right answer of your question correct. You may spend the whole day, the week, month to just get answer of one question. But if you are with the right person, you are on this straight road, which will take you to success, and I call it success highway. And that is what it is. And we will take all our students over the success highway to achieve their best. That's what this banner is all about. Okay. So let's continue. So as Hamza, you were saying, I've taken a very simple example here. We have taken a function, right? I just put in the values. The function here is f of x is equal to x. Very simple, right? So the reciprocal is 1 over f of x. Clear? Very simple. We will call this in general small rx. So when I say small rx, I mean the reciprocal function. Capital R I will use for rational function. Is that okay? So it will be like kind of easy for us to communicate. So as I was saying, if my value of f of x is -2, then 1 over f of x will be -half, correct? So f of x values are like -2, -1, 0, 1, 2, minus infinity, plus infinity. I have written the reciprocal values of the function. Do you see, compare these two? Does it make sense to all of you? So what do you notice? Negative, 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 negative. Do you see that? Positive, 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 positive. Perfect. Then you also notice that these two are same. Reciprocal of 1 is 1. Reciprocal of -1 is 1. Correct? We call them invariant.
Also the same too?
Pardon?
Isn't this one, the one after this, the 2 and the 1 over 2, isn't that also the same?
No. 2 has changed to 1 over 2. So on the function, if you have a y value of 2, then on the reciprocal,
Okay, that's, I thought it was a transformation that 2 became 1 over 2, like the reciprocal
no,
of 2 would be 1 over 3.
Yeah. So function f of x and its reciprocal. Is that clear?
Okay.
Now,
Yeah.
very important thing is to understand this part. If the function has a 0, function has a 0 means what? Means x-intercept, correct? This value, x-intercept, means f of x is 0, right? In this case, it happens to be at origin. That's fine. But when the function has a 0, 1 over 0 is not defined. So we'll have infinitely large value. And that will result into a vertical asymptote, correct? Now, if the function is approaching negative infinity, do you see the function is approaching negative infinity, right? Oh, sorry, this was a reciprocal. The function is approaching negative infinity, as you can see here. In that case, what happens to the reciprocal function? It approaches 0. Because very large number, if you divide by, you get a very small number. But if the very large number is negative, that 0 will be negative. So therefore, we will always put this as 0 from negative side. It is still in quadrant 3. You get the idea? The graph is in quadrant 3, approaching 0 from negative side, below the curve, below the x-axis, correct? When the function is approaching positive infinity, then reciprocal is approaching 0 again, but from the positive side. You see that part? Above the x-axis, and that gives you the complete information of when we plug in the values, as Hamza was saying, then the reciprocal values will definitely be there, but we can also understand many things from it. Hamza, I'd like you to read what are the observations from these values. Yes,
Okay.
Can you? Yeah.
Okay. So reciprocal of positive number is positive. Okay. So the reciprocal of a negative number is negative.
Correct.
Reciprocal of a number less than 1 is greater than 1.
Correct.
And reciprocal of a number greater than 1 is less than 1. The reciprocal of infinity large number is extremely small. The reciprocal of infinity small number is extremely large. The reciprocal of plus minus 1 is the same invariant.
That is an invariant point. So that means the two functions will intersect at plus and minus 1. The two functions will intersect at plus and minus 1, as I am showing you here. Is that clear to you?
Sir?
Yes.
So for any function, is plus and minus 1 the only invariant points, or
Yes.
will there be more?
No.
Just plus and minus 1, right?
Y equals to plus and minus 1. A function may go like many times through it. That's a different story. But a horizontal line at y equals to 1, wherever it crosses the function, invariant point. Horizontal line y equals to minus 1, wherever it crosses the function, invariant point. So if I tell you to sketch reciprocal from the function, then very clearly draw a horizontal line at 1. You know, these points are going to be common. Simple as that, correct? Then you also know that if you mark the x-intercepts, you need to draw a vertical asymptote there. Very good, correct? If you know the end behavior, you know you are approaching 0. So you know those ends also, you know the center points. You have actually sketched the major part of the graph for reciprocal function, correct? And you can take some simple values where the function is minus half. You could take f of x as minus half and plug it 2 there also, correct? Because I didn't take so many values, but you could, correct? Depending on what type of graph you're working with. Is this point absolutely clear to all of you?
I have a question.
Yes, please.
So
yes.
the last one, the negative infinity becomes 0, and then there's a minus sign. And can you explain that, the last two?
Sure.
I don't really understand this.
Good question. X approaches negative infinity, where we are saying f of x approaches, f of x is the y value, correct? So this is going to negative infinity, right? F of x. Here, f of x is approaching negative infinity, correct? So what is happening to 1 over f of x? If you divide by a large number, you get a very small number. If the number is negative, your reciprocal is also negative. So you are approaching 0, right? But you are below the x-axis. So therefore, I'm writing 0 with a negative sign there. Correct? You have to watch my video on does 0 have a sign? 0 does not have a sign. Yes. But now we are at a much advanced level. We should understand that for many practical values, we are never at 0. We are only close to 0. Correct? Like here, we are close to 0. But you see, we are negative. So 0 does have a sign when you are approaching it from different places, right? And there is an approximation involved. So here, the 0 is negative, and therefore we write 0 with an exponent like minus, saying from below the x-axis, we are still in quadrant 3. Yes.
Sir, so when we have f of x equals to positive infinity, right?
Yes.
Then you would be approaching 0 from the right side, correct?
From top.
From top.
We say
above
top
the
and
x-axis.
Correct.
Right.
So from top, you are in quadrant 1. Be clear about it. Right? So infinitely large value in quadrant 1. Once you start thinking like this, things will fall in place. You will have no difficulty in this chapter. You will sail through it, I'm telling you. Is all this absolutely clear to you? All of you. Ankita, is that clear to you?
Yes, sir, I understand that.
Hamza, did you understand that plus infinity and plus 0, right?
Sort of. So basically, it's like if you were to think about it, if f of x is approaching infinity, it would be like 1 over infinity. Is that just
0
basically equal to 0?
Correct.
Is this okay? So is that just something we should memorize, like every time we see it? That
Oh yeah, it's like common sense now, right? Basically, we are saying if you divide by like 4, what do you get? You get 1 over 4, which is small. But if I have 10, 1 over 10 is even smaller. If I have 1,000, 1 over 1,000 is almost 0, correct? 0.0001.
Oh, okay, that makes sense now. Yeah, okay.
It is 0 only, correct?
Yes, yes.
1 over 1,000 is 0.001. If you are working in 2 decimal places, what do you get? You get 0.
And then you keep going like 1 over
value.
Okay.
You get the idea?
Yeah.
Which many students do not understand.
Okay, I think you explained that. I think that's what I need to. Okay.
Minus 1,000 will give you 1 over.
And then it will keep getting smaller because it's approaching infinity. So the higher the value, the smaller the. Okay.
So you can see from the graph,
yeah.
How is it approaching 0? Correct? From
okay.
above.
Okay.
So so now all of you, is this point very clear? Reciprocal values and how we are going to relate it with the graph, right? Let me take it once again. So now we are going to look into the characteristics of reciprocal function, which we just summarized a bit, right? So now I'd like you to participate and tell me exactly how are the characteristics of the reciprocal function related with the function itself. So this time I've taken the graph of a quadratic function, right? So here, let the function f of x, let the function be f of x and the reciprocal be 1 over f of x. So now we have taken a function which looks like a quadratic function, right? So we have a function, we have defined f of x this time as, it looks like x square minus 2 to me, is it? So the parabola has been brought 2 units down, translated, and therefore it does have x-intercepts. And those x-intercepts are at, it has 2 x-intercepts, and these 2 x-intercepts are at minus square root 2 and plus square root 2, correct? Correct. And I have actually given you the graph of reciprocal in dark blue color here, right? Let us try to understand how are these 2 graphs related. Earlier we did with a linear function, very simple. So here we have a quadratic function with 2 zeros, means 2 x-intercepts, correct? I will like Akshat first. Observations, we'll straight away read the observations and then look back into it. So Akshat, can you please read the observation and then all of us will say, have we understood or not? Correct, Akshat, read.
Yes, sir. Observations. Graph of R of x is positive when f of x is positive. Graph of R of x is negative when f of x is negative.
Is that clear
Graph
to
of-
all?
Yes, sir.
Okay. Reciprocal is R of x. F of x is the function. If the function is positive, then the reciprocal is also positive. If the function is negative, then the reciprocal is also negative. Correct? Read further, please.
Graph of R of x increases when f of x decreases.
Yes.
Graph of R of x decreases when f of x increases. Sir,
Right.
I have a question on that.
Yes. Ask.
Sir, so when we say graph of R of x increases when f of x decreases, right? So can you draw like display where
I
the
will.
increasing and decreasing is?
What is happening to the graph of the function in this portion, Akshat? Can you tell me?
It's decreasing, sir, the green one.
And what is happening to the reciprocal?
Oh, okay. Yeah, it's increasing.
You see
right.
that? Increasing,
Yeah,
right?
yeah.
From 0 to some other positive value, right?
Right.
In this portion, it is increasing. Do you see increasing?
Correct. Yeah.
And in this portion, the reciprocal is actually decreasing, going to 0, positive, right?
Right.
Okay,
Correct.
Continue.
So graph of R of x intersects a graph of f of x at f of x equals to plus or minus 1. So this is the invariant points, right, sir?
Do you see those 4 of them?
Yeah.
Clear to everyone? Correct? At plus and minus 1, we will have an invariant point common to both function and its reciprocal. So if I give you the function and I tell you to draw the reciprocal of its function, first thing you will do is mark those points which I have marked in orange. They're at plus and minus 1, correct? Does it make sense to you? Simple as that, correct? Next point.
Y equals to 0 is the horizontal asymptote for R of x.
Simple. You don't have to think. You know 1 divided by the function. If the function is going to be very large, then the reciprocal is going to be very small, 0, approaching, correct? It will never be there. That means there's always a horizontal asymptote which is at y equals to 0. And therefore, I will always draw a horizontal asymptote to begin with if I have to sketch a reciprocal function. Is that clear to everyone?
Yes, sir.
Next point.
R of x has a vertical asymptote at x-intercept of f of x.
So it means that if the function has a 0, 1 over 0 is infinitely large. Therefore, there should be a vertical asymptote. So at the x-intercepts, I am going to draw this vertical asymptote. Do you understand? Is that clear to you?
So it has 2 vertical asymptotes in this case, right?
You are right. So these are your vertical asymptotes at plus and minus square root 2. You get the idea?
Yes, sir.
So those x-intercept, draw a vertical line dotted showing the vertical asymptotes and a dotted horizontal line on the x-axis showing the horizontal asymptote. You got the asymptotes in place, right? You also got the invariant points. You have already scored half of your sketching marks because key points are already there on your graph for the reciprocal function. Do you see that part? Now it is only the question of increasing, decreasing. You know, positive will remain positive and increasing becomes decreasing. You can now sketch the rest of the graph without any problems. But for the accuracy, you can take few points. For example, the good points will be take the values where it is half plus or minus or 2 plus and minus, right? We already have 1 plus minus, right? And that will give you 2 more key points on each side, positive or negative, and you can accurately sketch your graph. The graph characteristics will be kind of like a reciprocal. So everywhere the graph will look like that curve as you see in reciprocal. Is that okay? Shape of the graph. Correct? Last point. Akshat, can you please read y-intercept?
Yes, sir. Y-intercept of R of x is reciprocal of f of 0.
Correct. So reciprocal. So in this case, minus 2 is the y-intercept for this particular function. If I put x equals to 0. So reciprocal of minus 2 is minus half. So I have that point on the reciprocal which is minus half. Do you see that? I've got the y-intercept of the reciprocal function also. You get the idea? Yes.
So the y-intercept of R of x. So R of x is denoting the reciprocal, right, sir?
Yes.
So in this case, where would we see the y-intercept of the reciprocal?
Here. Reciprocal half.
Okay, yeah, that's where it touches the y-axis. So that would, okay, so it's the reciprocal of f of 0, right?
I should write minus, right? And this is minus 2. Do you see that? So on
Right,
the
right.
function, the y-intercept was at minus 2. So on the reciprocal, it is at minus half. Reciprocal means 1 over that value, correct?
Yeah.
You got the key points of your reciprocal function just from the sketch of the graph. Now, the graph could be anything. The function may not be known to you. I could sketch anything. You can sketch a reciprocal. Do you see that? That is what happens in the test paper. They don't give you x square. They just sketch a rough thing, right? And they say, now sketch the reciprocal. So first thing is you find the invariant point, you find x-intercepts, that will be converted to the vertical asymptotes. You see the end behavior and draw the horizontal asymptote at y equals to 0, correct? You got your framework. And then you fill in the rest, knowing all these characteristics. Is this concept clear to you, please? Absolutely clear, right? So we have understood without reading anything about the reciprocal function yet. We haven't really started reading the chapter, correct? Before that, we have understood 75% of the chapter. That's the beauty. You get the point. The book will start with some question somewhere and will land nowhere. But here, we can actually begin with the questions in the book, and we will be able to answer 75% of the questions in the book from what I have told you so far. You get the idea? That is the power. And now let's see some simple example. We also considered how will a linear function look like and how a quadratic function will look like. And therefore, we can quickly go through their graph. Is that clear to you? Ankita, can you please read what has been written on this particular screen?
Yep. Sketch a reciprocal of linear function. Sketch the function f of x equals x minus 2 and its reciprocal r of x equals 1 over f of x. Key value. Should I continue?
Yeah, no, correct. So that is your thing. Now you tell me, how will you do it? What is going to be your approach to sketch a reciprocal function for this linear function? X minus 2 means y equals to x has been translated 2 units to the right, correct?
Yep.
You could definitely sketch this function. I'm saying that is not difficult at all, correct? So anybody could sketch y equals to f of x. We have done it so many times. There you go. But now we have to sketch the reciprocal of this function. So what strategy are you going to adopt to sketch the reciprocal of this function? Ankita, can you please tell me, and then we'll follow you. Yes.
A little unsure on how to start, but
Okay.
I feel
Try. How will you start? What is going to be your approach? Will you follow the approach of key values or will you follow the approach of graph? We have learned actually 2 techniques without saying that we have learned 2 techniques, correct? So we learned a technique about finding the key values. As Hamza was saying, he prefers to find the key values and then put the reciprocal, plot the graph using the values, correct?
Sure.
Yes, Hamza? The second is, we have also learned the characteristics from the graph. We could use either of these 2 methods to sketch. Is this part clear to you, Ankita? So we have 2 methods. Is that clear to you now?
yeah.
But sorry.
Yes.
I think I would prefer the second one, like the plugging the values in, obviously, because I think that you can't really go wrong with that. Like, you know,
Correct. Calculations are involved. Correct.
Yeah.
So mixed. We always will have a mixed approach. I'm not saying one is right, one is wrong. No. Both have their advantages. When it comes to accuracy, the numbers count. When it comes to accuracy, you have to mark 5 points very clearly in your graph to get full marks, right? Those 5 points are from the key values, correct? And then it is the smoothness of the curve, the accuracy of the curve, the behavior of the curve, which gives you rest of the half marks. So both are important, correct? So Akshit, can you summarize how will you use key values and figure this out?
Yes, sir. Sir, before I do that, I have a question.
Yeah.
Sir, so when we say let the function f of x equal to x minus 2 and we have to find the reciprocal, right, sir?
Yeah.
So the reciprocal would be 1 over x minus 2, right?
Correct.
So
In
can
this
we...
case, 1 over x minus. Yes.
So can we draw 1 over x, right? And then just move every point to units to the right?
We will not adopt that approach. We have already seen parent function transformation. That job is over, correct?
Right.
We're trying to understand techniques of sketching a reciprocal function, which could be anything. I'm just, because we're beginning to do, right? So I will say like let's say this is my function. Is that clear to you, right? I'm just drawing something. Now we don't have any function equation to work with. How do I sketch the reciprocal of this function? Tell me.
Right.
Now, to sketch it, what will I do? Definitely, I need some local maximum, minimum, and critical points to start sketching the curve, correct?
Yeah.
And what I will do is, I will draw a line which is y equals to 1. I mean, let me use a color which is different from what we have here. Let us say this is y equals to 1. Is it okay? And then I'm drawing it big and bold so that you understand how we are trying to do it, right? -1. And as soon as I draw that, I know these are my invariant points. They will never change, correct? So many points I have got without doing any calculation. For the reciprocal, correct? 1 reciprocal is 1, -1 is -1, correct? Is that clear to you? Then I will say my horizontal asymptote is this, because y equals to 0 is my horizontal asymptote.
So, and your vertical asymptotes would be your x-intercepts of.
Vertical asymptotes are the x-intercepts, right? Just see how this is a beauty. I mean, this method which I'm discussing with you is something which you will appreciate when the school begins. And now we know reciprocal is 1 over x graph, correct? We have some values. Let me just put some values, to make it look like more accurate, right? It is. So let us say that this maximum value is, let us say this maximum value is 2, okay? That means the reciprocal will be half, correct? This will be half, correct? This value is -2, let us say. So this will be -half. You get the idea? Similarly, I could take some more values, connect those and sketch my graph. Do you understand? It is too complicated because it's too small, that's why. But I think you got a gist of it. How do we sketch reciprocal of a complicated function, right? Now, let me show you here, which is simple graph, but that is one. You think like this. This section is this section, correct? If you know section by section, you can sketch the whole graph, correct? There are 3 lines, right? This could be similar to that, correct? Does it make sense? So we'll go with the Hamza approach first, which is just plug in the values of x, get f of x, correct? And find r of x. 0 gives me a vertical asymptote, 1 gives me 1, 2 gives me half, approaching infinity gives me approaching 0, plus infinity means +0, minus infinity means -0, and I've got all my points. So these values of reciprocal function, which is right there, will accurately give me the graph. Agreed. But now see the beauty, without those calculations, what am I going to do? I know at 1 it is invariant, so I'm marking my invariant points. Do you see that one? This is +1, this is minus invariant point, correct? Then I'm saying x-intercept is a vertical asymptote, so I'm drawing a vertical asymptote here. Let's enlarge this. And I know this is like, in this case, it is x equals to 2, right? Because at 2, we have a vertical score. We are looking into the function, which is x minus 2 now, reciprocal, correct? Now, and we know that there is a horizontal asymptote, which is y equals to 0. Correct? So this is y equals to 0. Horizontal asymptote. That is your vertical asymptote. Is that clear to you all? Now, since I have the vertical and the horizontal asymptote, now I have to only sketch the reciprocal function. What I'll do? Very simple. I may find the y-intercept. Y-intercept is 2, reciprocal of 2 is half. You see that? So I have my y-intercept also. Do you see the reciprocal function in green? This is what I'm saying, r of x. Done. Within a second, I am going to draw this graph accurately. No marks deducted. If the question is sketch. If the question is graph, then I will mark a point which will say, well, this was 2, my point is half here. Do you see that? You get the idea? If it is -2, in that case, the value, this is like -2 minus half. You see that -2 marked as minus half? I'm done. This is the graph which is required. I have my vertical asymptote, horizontal asymptote, and the points which are invariant points at plus and minus 1, correct? So we have invariant points. Let me write it down. Invariant. You will get 0.5 marks for this also. Sometimes a part of the question is which points are invariant in your graph. You have to mention both these points as invariant points. You get the idea now? That is how you're going to sketch reciprocal of a linear function. And remember, most of the functions could be split into 2 types of function, whether it is linear or it is non-linear, correct? If it is linear, follow this section. This is, I'll call this as linear section. For example, the graph which I gave you, let me just come down to this. This will be 3 linear sections, right? But they're all linear, similar kind of graphs, correct? So there may be 3 vertical asymptotes. Near every vertical asymptote, we have a graph which we have drawn here as a reciprocal function. Is this part clear to everyone? Any questions, please? Beautiful. So now let's look into the slightly more, so that's the solution, correct? So this is just the solution we have drawn. You're very clear that we have to clearly indicate the 2 vertical asymptotes. Let me draw in a highlighter. Okay, so let's put this. Okay, so we have this highlight. I'm just very boldly doing it. Y equals to 0 is a vertical asymptote, and this is x equals to 0. X equals to 0 is a vertical asymptote, y equals to 0 is a horizontal. You have to mention this. You have to mention these 2 points. We say invariant points. Do not forget this. Otherwise, your 90 plus is gone. Invariant points. Do you understand? So you'll mention the invariant points where the value of the function is either +1 or -1, correct? And then you have to also mention the y-intercept.
Sir?
Yes, sir.
Sir, realistically, if they give us a function, let's say f of x equals to root of x minus 2, right? We follow the same steps to find the reciprocal, right?
Yes. Same steps. And domain. Now, domain of the reciprocal function, we know now that f of x is not equal to 0, correct? That gives you the domain. So we'll write domain is x belongs to real numbers where x is not equal to 2 in this particular case, since the function was x minus 2. Is this clear to you? Range. Range is all real numbers except y equals to 0, right? So we'll write range. So range is what? Range is y belongs to real numbers so that y is not equal to 0. Is this clear to you? For all reciprocal functions, range is going to be what I have written just now. Is that clear? Except for one, I'll give you exception also. Yes. We'll move on and take up the quadratic function now. And now we'll do a quick exercise on this. I would like Hamza to tell me where are the vertical asymptotes. I want to draw the reciprocal of this function. My function is x squared minus 2. I need to draw the reciprocal of this function. So Hamza, it's just a review. Where are the vertical asymptotes? Tell me.
Vertical asymptotes. Quadrant. So it would be one would be on the left side, one would be on the right side. Is that what you're trying to do?
So wherever the x-intercept was there, I'll mark that point, draw a vertical line. These are my vertical asymptotes. Clear, right?
Yeah.
So simple, right? So horizontal asymptote. Do you see that? Y equals to 0. Do you see that? Right? Invariant point. Invariant point is where it is 1, correct? So this y equals to 1 is here, and this is here, and then -1 is here, correct? Invariant points. So once I know that these are the invariant points, I am going to go up here, right? and down from here, approaching 0. Do you see that graph? Invariant point. Do you see how I have drawn invariant point, right? But now, y-intercept -2, for the reciprocal, it will be at -half, correct? So now with -half and invariant point, I can go down. Do you see from -half to invariant point? Where is in? Sorry. The invariant point is at 1, right? Here, right? So in -1 and invariant point, I go down, right? It has to be a smooth curve, right? And y-intercept. How much time did we take? Nothing. If you start calculating the values and making the table, to draw the lines of the table, you take more time than draw the curve. You get the idea. Do you understand? Correct? So understanding the characteristics and the power of what we have learned helps us to quickly get through all these solutions. Is this clear to all of you, right? Correct? So, so that's where we kind of will end. But, since, we have done, we have understood all this, let's take up a question. So let's make a question. Which type of graph do you want, Akshit?
Sorry, let's try a root function this time.
Square root function. Let's try a transformed square root function, correct? Okay, my dear. There you go. Does it look nice? Good job. So that is some transformed square root function. We don't know what it is. We'll just call it f of x. Is that okay? Because we don't need any points. We don't need anything to draw the graph of 1 over x, but we need the understanding of the characteristics of a graph. So first thing first, from where should I start? Let me give you some values. It becomes meaningful, right? So let's say this value is 2. Is that okay? And this value here is at, let us say 3, okay? 2 values, not more. Okay, let's say this value is 4 minus 5. Is it perfect? Minus 5, right? At 4, this value here is minus 5. Now we will perfectly do our job. Is it okay? Now, let's try. So from where, Akshat, will you start? You selected this, now you deal with it now.
So first I'll draw the vertical asymptote at 3.
Okay, so vertical asymptote at 3. Good job.
And then the
as soon as you draw,
asymptote.
Akshat, don't leave things. As soon as you draw, right, y equals to, vertical asymptote, x equals to 3. Is that okay?
Yeah.
Vertical asymptote, right? You are getting full marks because of this, correct? Second thing
would be the horizontal asymptote at x equals to 0.
Correct. Dotted line, I'm just writing bold. Y equals to 0, horizontal asymptote. Is this clear to you? Correct? Third.
Right. And then after that, so you have a point 2, right, sir? So that would be your y-intercept. So then now your point would be 1 over 2.
Correct. Very good. Half. So you got, now we are plotting the points which we are going to connect, right? Half. Another point. 4 minus 5. Where will this go? 4 minus 5.
Sir, so what would you do with that point again?
Minus 5 becomes minus 1 over 5, but it will remain at 4 only, correct? So this point here will be,
okay, so you flip the y value,
4
right?
minus 1 over 5. Is that okay?
Right.
Very important point, because this is one of the end points. This is going to give you domain and range, correct? Very important point. You cannot leave this. Correct? So we got this. Now we have to see where is minus 1 and plus 1, right? So half of this is minus 1. So we got this invariant point. And here minus 1, let us say this is minus 1. And so invariant point. Is that okay? Invariant point. Can I sketch the graph now? We know that is the horizontal point. This is invariant point. So there you go. And there you come. I mean, because this is a vertical asymptote, correct? Is that clear to you?
Sure. So it always approaches the vertical asymptote, but really never meets it, right?
Because it's negative infinity, right?
Right.
Now this is positive, but the invariant point is here. So positive, it will go up, correct?
Yeah.
And this place, go through this. Go through the y-intercept.
Okay. So it's supposed to be a smooth curve, right, sir?
Yeah, it has to be a smooth curve. It has to be, the curve will be always like 1 over x curve. Do you understand?
Yeah.
That 1 over x is the curve everywhere. It could, even if it is going like this, it is kind of 1 over x. You get the idea? Do you see your graph now?
Yeah.
Now here we have to stop this place because this was a function which has the restrictions. Will stop here only. Do you see that part? Very, very critical. We have stopped here because the graph is no more on the right hand side. When x approaches positive infinity, does not exist. Only this approaches negative infinity. In that case, y approaches 0 from the positive side. You get the idea? You cannot approach positive infinity because the function has a restriction in domain. Now, can you give me domain range for the function? What is the domain of the function now? Reciprocal function, I'm saying.
Sir, I have a question really quickly.
Yes.
Sir, so when we say x approaches negative infinity, right? So when x is approaching the negative numbers, so we approach 0 from the right side, sir, above the x-axis?
Yes, therefore I wrote 0 plus above the x-axis, correct?
Okay.
This is approaching negative infinity, correct? Yep.
So we don't consider the right side of the reciprocal function
because there is a restriction. The minimum value of the square root function is 4 minus 5, right? So nothing beyond 4, correct?
Right.
X minus 4. You get the idea, right?
Yeah.
And minus outside because it just got reflected.
Okay.
So we don't have the equation, but we can think what it is. So what is the domain of this function? Can you tell me the domain of this function? X belongs to real numbers. What are the restrictions? 1, x is less than equal to 4, correct? And x is not equal to 3. Do you see that? You have to add both the restrictions. On this left side of 4, however, it cannot be 3 because that is your vertical asymptote. Is this clear to you, all of you?
Sir, so for the range, would it with the restrictions?
Y not equal to 0.
Right, that's it, right? Right.
Because the vertical asymptote is right there in between, so it will go to plus and minus infinity, right? So this is going from left, right? This is going from left. And this is approaching from right. Sometimes they ask you in grade 12, from where are you approaching the vertical asymptote? This is what you will write. Is that clear to all of you now? We'll end our class here. So I'd like you to summarize what have you learned today. So one by one, let's start with Ankita. Ankita, what did you learn today?
Sure. We started with the reciprocal functions for advanced functions, and we did learn this in grade 11, but I think we went much more into depth in this class, along with learning efficient methods in order to graph the reciprocal function once you're given the parent function. So I think those are the things I mainly learned today.
Very good. Vishruta, how about you?
I learned that how to go into really deep with reciprocal functions. I learned the 2 methods of using it, applying it in test questions, and how I could benefit and get the most marks out of it.
Very good. Hamza.
I learned about the characteristics of reciprocal functions. I learned how to graph it, how to sketch it, how to find the asymptotes, which I didn't really know. I knew the reciprocal function, the basic ideas. The 1 become if it was 2, it would become 1 over 2. I knew that, but I didn't really know the graph. I knew a bit of the parent function or reciprocal function, but I didn't really know about the graphs and the characteristics. So I learned that today.
Very Akshay.
Yeah, sir. So I remember in grade 11 we touched upon, I think it was vertical asymptotes, but we didn't go into horizontal asymptotes. So it was pretty cool to learn that, and I really found it useful how we can just find the solution just like that, and like so it's gonna conserve a lot of time for me in the tests.
Some of the teachers are really upset from my students when they provide solutions like this. This teacher will give such a difficult graph to deal with, and my student will just mark those 5 points and sketch the graph, and that's it, done. And full marks. So that is the beauty of today's lesson. I hope you appreciate it, and you'll appreciate it more in September when the schools reopen. Okay, so we'll end our class here and look into something very intricate about reciprocal functions. I'll actually take semicircles and then begin rational functions in our next class. Okay, great. Thanks. All the best.
Thank you, sir.
Bye.